ये या भितर कहीं लगेच एटा से दूर पाऊनी बोली ना कौन अच्छा हाँ आरंभ करिया आरंभ अच्छा students will take this class on equations of rotational motion, center of mass of a rigid body which is a system of particles, then center of mass motion. I presume that you already know the linear motion. Now, when I talk about a particle undergoing a linear motion, that means you have a when there is a particle means it is a point mass which has no dimension, that means it has no length, no breadth. So, you say that it has no dimension, then we say it is a particle. It has no extension, it has no area, no volume, no shape, it is a point. Now, such a particle undergoes a linear motion when it moves in a straight line from A to B, it moves in a straight line, then you say it is a linear motion. In linear motion, the particle has been displaced from A to B in this direction along a line. Then you have also read about, so this is our linear motion. You have also read about a circular motion. Here is the particle of mass m. It moves in a circle about a center O. So, in circular motion you have read about centripetal force. You have also read about, starting with, just like here the displacement you say as S from A to B. In the case of this circular motion, so this is the case of circular motion where the angular position is determined by, you fix one reference line. From that reference line, if the mass has moved from here to here, now initially it was at t is equal to 0, the mass was here, at time t the mass is here. So, it has this reference line or the radial vector has crossed through an angle theta. So, it has moved through an angle theta. This is its angular displacement or angular position is determined by the angle it covered, the angle covered by the body. And we define, as in this case your S by T was your average. In linear motion, average speed is distance covered per unit time, S by T. In case of angular or in case of circular motion, or we can say the rotational motion, the angular position is theta, instead of S it is theta. So, here the speed is angular speed. So, angular speed is this you have covered in circular motion, angular speed, the average value, that is why I have put a line over the omega. So, this is equal to theta by t, and instantaneous angular speed will be d theta by dt. This you already know, and you have also found out that because this length, if this is S, this is r, then your S equals to r theta. So, if S is equal to r theta, the derivative of S will be your V. So, V is equal to r theta d theta by dt. If I ds by dt is equal to r d theta by dt, r constant, then d theta by dt will be omega. So, V equals to r omega. This you have read in your circular motion chapter. Further, I will take you further to this rotational motion, that what happens when omega changes. This is the case of, you have read about uniform circular motion, in which case the linear speed was constant. Mark the difference, speed and velocity. When I say speed, means it is a simply, it has magnitude only, it is a scalar. When I am saying linear velocity, means I am talking about also the direction. The linear velocity is always along the tangent. Here it is along the tangent. At this point the velocity is along this tangent. So, the linear velocity changes from point to point in a circular motion or a rotational motion. The linear velocity keeps on changing. Now, depending upon the type of motion you have, if it is a uniform circular motion, then the magnitude is constant or linear speed is constant. That means it takes the same time to cover the entire thing, entire 2 pi. And remember, this angular theta is measured in radians, and 2 pi radian is equal to your 180 degree, that you are saying is 2 pi radian. So, accordingly you can change what is 1 radian will be around 57.3 degrees. So, what happens when omega changes? The angular speed changes. So, angular speed is the change in angle or rate of change of angular position, or rate of angle covered per unit time is angular speed. Now, suppose a body is moving with changing angular speed. So, if the angular speed, what is angular speed? Means the time to cover this entire thing. How much angle, if 2 pi angle is covered in, suppose the 2 pi angle is covered in time capital T, then capital T is called the time period. That means it takes T time to complete one circle, that is its time period. Then the angular speed will be 2 pi angle covered divided by time taken. So, 2 pi by T will be our omega, and 1 by T is called the frequency. These things you have already read. So, I am not going into the details. F is here frequency, number of cycles per unit time. What happens when this omega is not constant and it changes? So, when omega changes, there we can define what is angular acceleration. So, angular acceleration will be similarly, it is denoted by alpha, and the average value is the change in omega, delta omega, or omega is the change per unit time, or delta omega by delta t. In delta t time, if omega changes by delta omega, for example, I can have at time t, t2 minus t1, at time t1 omega was omega 1, and at time t2 omega is omega 2. So, this is the change in omega. So, change in omega, ମୋ ସାଙ୍ଗରେ ତ ଏମିତିଆ ହେଉଛି, ଗତ ଥର ବି ସେୟା ହେଇଥିଲା ଆଉ କୋଉଠି ଥିଲି ମୁଁ। So, angular acceleration will be change in omega by time taken. This is the average value. Similarly, the instantaneous angular acceleration, this will be alpha will be equal to limit delta t tends to 0 delta omega by delta t, which is represented as the derivative of omega with respect to t. Okay. So, this is the new definition, angular acceleration, rate of change of omega is angular acceleration. So, in case of linear motion, you have read about 3 equations. The equations of motion in this case, V equals to u plus at, S equals to S is equal to ut plus half at square, and V square equals to u square plus 2as. So, these are the 3 equations of motion in linear motion in this case. What are the equations of motion in angular case, in the case of circular motion or rotational motion? So, those are the equations of rotational motion. So, to derive the equations of rotational motions, we will go through the same methodology that we followed in the case of linear motion. How did you find out v equals to u plus at? From the definition of acceleration. In this case, if you remember, acceleration was dv by dt, the rate of change of velocity per unit time. So, from that dv equals to a into dt and you integrated. Similarly, in this case, what we will take is alpha equals to d omega by dt. Compare the equation. Here a equals to dv by dt, here alpha equals to d omega by dt. So, this gives me d omega will be equal to alpha times dt, where dt is the time, omega is your change in, or omega is angular speed. D omega equals to alpha dt. Now, if alpha is constant, so I presume alpha is constant, that means the angular acceleration is not changing, it is a constant uniform, the value of alpha remains constant with time. Then I can integrate it, d omega I will integrate the left hand side, integration on the right hand side. Dt, now the lower limit and upper limit will be for time from 0 to t, omega, the limits of omega will be when time was 0, omega let us say omega 0, and at time t omega is omega. So, that means at time t equals to 0, the angular speed was omega 0, at time t angular speed is omega. So, these are the angular speeds. So, if I integrate, this will give me omega, lower limit is omega 0, upper limit is omega, this equals to alpha is a constant. So, it will come out. So, alpha is coming out, dt ra integration from 0 to t is simply t, and talata 0 achi, so it is from 0 to t. So, if I put these values, what I get is, this gives me omega minus omega 0, the value of omega when at upper limit minus value of omega at lower limit. So, omega minus omega 0 equals to alpha t, or I get omega equals to omega 0 plus alpha t. So, this is my first equation. Compare this with v equals to u plus at. This was the equation here. In linear motion, v equals to the final velocity or velocity at time t equals to, it is linear velocity. So, linear velocity at time t equals to linear velocity at time 0 plus acceleration into time. Here the angular velocity at time t equals to angular velocity at time 0 plus angular acceleration into t. So, the equations are very similar, but v is replaced by omega, u is replaced by omega 0, a is replaced by alpha, time remains the same. So, this is the first equation. If I come to the second equation, s equals to ut plus half at square, that means distance, how much is the distance covered by the body if it starts with a linear speed u in time t, if it has a constant acceleration a in the case of linear motion. Similarly, in this case, so here I will use the formula for s, ds by dt. So, here I have already used d omega by dt is alpha. Now, I will use this equation, omega equals to d theta by dt. Remember, in linear motion distance is s, in angular motion or in rotational motion or in circular motion is a special kind of rotational motion, in which case the body is moving in a circle, it is always at a constant distance from a center, from some fixed point, it is always at a constant distance, and we say that it is moving in a circle. So, it is a circular motion. Otherwise, it is also an example of rotational motion. So, distance is s, in this case the angular position is measured by theta. So, instead of s I will get a equation in theta. So, I am using omega equals to d theta by dt. So, as before I did there, d theta will be equals to omega into dt, but omega is not a constant. What is omega? We have already found out in equation 1 that omega is this. So, I have to write omega, the value of omega from equation 1, that is omega 0 plus alpha t dt. So, now I can integrate, because this is constant, alpha is constant, t dt I can integrate. So, if you integrate it on both sides, omega 0 dt plus alpha t dt. Now, integration is from 0 to time t, from 0 to time t, and d theta, let us say at time 0 angle was 0 and at time t angle is theta. This integration will give you simply theta equals to, this will give you omega 0 into dt ra integration haba t, and t ra value put jodi kariba t minus 0, that is t, plus alpha. Now, t dt ra integration is t square by 2. So, t square by 2 at t is t square by 2, at 0 is 0. तेणु एथिरो minus 0 करथांती मु सेटा लेखिलेनी. So, this is my second equation. So, this is our equation number 2. Compare this equation with the linear motion. S distance, here angle theta equals ut initial speed into time, एठी initial angular speed into time plus half angular acceleration into t square, एठी अछि half linear acceleration into t square. So, it is the same equation. Linear motion, sum of the quantities are replaced in case of angular rotational motion. Then the third equation is v square equals to u square plus 2as, that means time is not there. So, I have to remove that time dt. So, what I do is in alpha, take this equation d omega by dt, I will remove this time. So, to remove this time I write it as d omega by d theta, तले d theta हरण कर देली, ऊपर एठी multiply कर देली, remains the same, d theta by d theta is 1 by dt. So, this equals d theta by dt definition अच्छी omega. So, this is omega d omega, omega एटा हला omega, एटा d omega divided by d theta. So, what I get is, if I take this to this side, I will get alpha d theta is equal to omega d omega. Now, integrate. If you integrate, on the left hand side it will be alpha d theta equals to omega d omega, starting from 0 to theta, and omega changes from omega 0 to omega. So, this gives me alpha is constant, I can take it out, alpha theta equals to, this is omega square by 2, omega 0 to omega, ता माने ये value टा at omega minus ये value at omega 0, ता माने मु आगो अपर लिमिट टा लेखिली ओमेगा स्क्वायर बाय 2, जेतेबेले ओमेगा रा वैल्यू ओमेगा सेतेबेले एया हबो, माइनस ओमेगा रा वैल्यू जेतेबेले ओमेगा 0, ओमेगा रा वैल्यू जेतेबेले ओमेगा 0 हबो सेटा हबो ओमेगा 0 स्क्वायर बाय 2. So, if I rearrange these things, what I will get is एटा को आगो लिखिबी. So, ओमेगा स्क्वायर 2 टा को एठी की मल्टीप्लाई कर देबी, आ ये ओमेगा 0 टा को एपट को नै जिबी, ताको अरेंज करिकि लिखिली ओमेगा स्क्वायर विल बी इक्वल टू ओमेगा 0 स्क्वायर plus 2 alpha theta. Mark the same equation, v square equals to u square plus 2as, t time रे velocity रो square is equal to 0 time रो speed रो square plus 2 linear acceleration into distance. एठी हला t time रे angular speed रो square is equal to t is equal to 0 time रे angular speed रो square plus 2 angular acceleration into theta. Theta is the angular position, distance s is the linear position. So, this is the third equation. So, these are the three equations. You can, if you remember this and you know what is what, that means if you know in linear motion, if u stands for this, v stands for this, a stands for this, s and t, what are the corresponding quantities in angular motion or in rotational motion, you can always get the same equations. That means, if you have S is replaced by theta in angular, this is rotational motion, this is linear motion. S is replaced by theta, then u initial speed is replaced by omega 0, initial angular speed, this is speed at time t, now it becomes omega. In this case acceleration is a, in this case acceleration is alpha, time is the same. So, if you know these, the corresponding quantities of linear and rotational motion, you can always get the same equation. If you remember this, you know from your school days. So, there is no problem in remembering this. Simply remember these values are replaced by this in case of rotational motion. We will come to these equations of rotational motion when we complete the torque and other things. So, we will first move over to system of particles. What happens in case of a rigid body, when it, why should we define something called center of mass and how it moves, then we will again come back to this the equations of motion. System of particles. And I will talk about a rigid body. Till now we have been talking about a particle which has no dimension, no length, no breadth, no area, nothing, it is a point. But all bodies that we see, that we come across in physics, in matter, in everyday life, have some area, some volume, some shape, some size. So, they are not point masses, they have some extension. For example, if I take a simple scale, this scale has some thickness, it has a length, it has some thickness, it has a breadth. So, it has some dimension. I cannot treat it as a point mass. Then I can have a ball, I can have some rigid body, some shaped rigid body, or I have a certain mass of things. Suppose a ball of cotton, let us say this is a cotton ball, this is a stone, let me say this is a stone, this is a simple ball you play with, or this is a scale, let us say. These are all bodies which have certain shape, certain size, they cannot be treated as point mass. So, how to treat these things when they move, how to describe their motion, whether they are in linear motion, rotational motion or anything else, to study how the acceleration takes place, how the velocity changes or velocity takes place, all these things can be known. How do we do that? So, in these cases we consider them as system of particles. That means, we consider that this scale consists of many small particles. It is a congregation of many particles. So, this is a system of particles, and we will treat, can we treat all of them separately? That means, in particle motion, once we know we can write the Newton's law of equation, force equals to mass into acceleration. Because it is a point mass, it has only one mass, one acceleration. So, force, whatever is the external force, that is equal to mass into acceleration, simple. But when it comes a system of particles, there are many particles, let us say 8,000 particles. So, you will have 8,000 equations, because all these particles will have different force, they have different mass. So, they will have different accelerations. So, how we know that as a whole the system, how much acceleration is of this system? To find that out, we have to solve that 8,000 Newton's equations. So, this becomes very tedious and it is not possible actually. So, in order to reduce this work, we have physicists have found out a different method, some mathematical method by which we can know the motion of the system by knowing something else, not going into the details, going into each and every particle. Instead of going to each and every particle equation, we go make it simpler, and for that we define what is called a center of mass. Before that, I should tell you what is a rigid body, because we will be confined our discussion to a rigid body. See, if you compare the stone and the cotton ball, if I compress this will be compressed, the size changes, the shape changes, it is not a rigid body. Rigid माने कौन? तुम कहबो जने मास्टर सार हमर भारी rigid माने कौन? तांको जहा कहले भी से भारी fixed, किछि कहले भी मानिबेनी, से त जहा बुझिथिबे सेतिकी. Similarly, a cotton ball is very not rigid, whereas the stone is rigid. You cannot change the shape of the stone by just applying a little force. So stone is rigid, cotton ball is not rigid. गोटे माटी मुंडा, ओदा माटी मुंडा, सेथिरे ताकू जदि मु एमति प्रेस कर देबी, से ता शेपटा चेंज हे जिवो. Because it cannot oppose the change. It will change, the shape will change and the dimensions will change. So that is why cotton ball is not rigid. So this is a rigid body, this one is rigid, this is not rigid. So we will not talk about cotton ball motion or anything of that kind, we will talk about rigid body. Then what exactly is a rigid body? So we can define that a rigid body is a body in which distance between any two of its points, in which distance between any two of its points always remain fixed. Two of its points, you take any 2 points, is fixed, the distance between them remains constant, it does not change. So it is an unchanging shape body, is a rigid body. So we will talk about rigid body only. So that is why I defined the rigid body first, then I will come to the center of mass. So we will find out the center of mass of a rigid body. Now when I am talking about a rigid body or any body as such, it has a dimension, it has a length, breadth, height, or it may have some shape. So all these things are possible. So in that case, what are the different types of motion it can have? It can have a linear motion. For example, if this is a body, if I take 3 points A, B, C, then if this body has, I must draw the same shape because the shape does not change. So if it moves from this point to, from here to here, A to B, no, not A to B, from P to Q, then A has moved through a distance A, B has also moved through the same distance B, B to B dash, C has also moved through the same distance C, C dash. That means A dash, B, B dash, C, C dash are same. So then we will say that the rigid body has undergone a translational motion. In the case of rigid body, we talk not about usually linear motion, but we talk it about as a translation motion. So the body is under translation, translatory motion. So the distances are same, each point move through the same distance, then it is a translation motion. Now it can have a pure rotation. For example, you take a cycle wheel, let us say this is a cycle wheel, these are the spokes, and through this, let us say this is the axle, this cycle wheel rotates. So when it rotates, its distance is not changing, it is not moving from any point, there is no linear distance movement, but it is remaining fixed at that point, but about an axis, this is my axis, about this line, about this it is rotating. So this is a case of pure rotation. So how you will say that it is a pure rotation? That means if one point has moved, will move through an angle, let us say this angle, let us say 10 degree, if this point has moved through 10 degree, then another point will also move through the same 10 degree. So angular displacement is same, angle covered will be same, নহলে তো বডিটা ভাঙি যাব না, गोटे पार्ट जदि गला 10 डिग्री आ गोटे पार्ट कहबो नाइ मु 5 डिग्री जीवी सेमिति हेल तो बंका ही जीवो से साइकिल चकटा सो नो इट रिमेन्स सेम आमे कहूँ प्रथम रिजिड बॉडी इट्स शेप डजंट चेंज इट इज व्हाट इट इज तेणु गोटे पॉइंट जदि तुम देखो सेटा जदि 10 डिग्री गला तेबे आर पॉइंट आ गोटे पॉइंट भी 10 डिग्री बुलिबो से किए बापट एपट को जाउची ऑल ऑफ देम विल हैव एंटी क्लॉकवाइज मोशन इन दिस केस they will move anti-clockwise through 10 degree. So, if the angle changed remains the same, then we say that it is a pure rotation. Each part of the rigid body will pass through the same angular displacement, then it is a pure rotation. Now, there can also be a case where suppose this is a wheel, it is rotating and it is reaching here, from here to here. It has moved from this point P to Q, it is rotating as well as moving ahead. So, in this case the body is rotating as well as moving ahead, that means it has a translation, it is moving ahead in a straight line from this point to this point, as well as the each part of this body is rotating. So, gote chakate gadai daba, so that means that is rotating as well as moving ahead. So, this is a case of rotation plus translation, and usually we call this rolling. This is what is called rolling. The body is rolling. Rolling means it has a both a pure rotation plus a translation. So, in all these cases, if I want to study the in this case, well, every body has the same displacement, same linear distance. So, jone gote body ro mu jodi displacement kadi parli, then that is same for everybody, so it doesn't matter. But in the case of rotation and all these rotation and translation, what we find is that the motion of each part of the body is different, not same. All the part does not have the same velocity. This, if this point has 0 velocity, this has some velocity, this has double the velocity of the center one. In the case of rolling, you will see that this point is at constantly at rest, it has a velocity of 0, linear velocity 0, this has a certain velocity v, and this has a velocity 2v, 2 times the central one. And that is why if you take a photograph of a rolling wheel, you will see that the upper part is very blurred because the speed ta besi अछि, तेणु चित्रटा जेतबे फोटोटा उठिबो सेतबे सेही जागाटा भलरे देखा जिवोनी, एटा भलरे देखा जिवो, ए पॉइंटटा भलरे देखा जिवो, काहे ना इट इज एट रेस्ट. So, these are the things that we will come across, and that is why we need to study center of mass. I will give you another example. Let us say that somebody is throwing let us say is throwing a ball. Simple, if I throw a stone, suppose this boy is throwing a stone to his friend who is standing here, let us say. If he throws a stone, this stone will go a parabolic path and reach here, let us say. So, this is about a point mass, it moves in a parabolic path and reach here. But what happens if I throw let us say a rigid body, some body, let me say a bat or a something, you will see that this body will rotate. मु ताको रोटेट करिक फपाड़ी ता पाखु सी एमती रोटेट करिक बॉडीटा एमती रोटेट करिक एमती हला एमती गला तापरे एपट को एमती हेकी रोटेट हे जिवो. सो दिस बॉडी रोटेट्स and finally reach here, let us say. I am not very good at drawing, but what you will find that each part, this is moving in this direction, this is moving in this direction, here it is moving in this direction, here it is moving like this, these points are moving in this manner. So, the different parts of that body are moving in different way. But if you mark one of the points, this, if we will mark that this point will move in a parabolic path. So, this point has some significance because it retains the particle type of motion. Particle gote khali particle gote particle he jaitanta se gote parabolic re jaitanta. A bat ta gala belku it is not parabolic, not in exactly in each point is not moving in a parabolic path, but if you consider one of the points that will be, we will see that that point is called the center of mass, which will pass through that same parabolic path. So, this is, that is why we want to read about center of mass. So, center of mass, let us say, this is why center of mass is important, and is a point which behaves, this is a point, this has no, actually this is a definition. We are mathematically trying to define something which will make our work easier, to tackle our problems it will be easier. So, is a point which behaves as if the entire mass of the system is concentrated at that point, and all external forces acting at that point. So, that means instead of the rigid body or instead of the extended body, what we can replace it by a point mass whose mass will be equal to the mass of the rigid body, and we will see that this mass will behave as if the entire whole that point mass is experiencing all the external forces. So, if we have 2 points, let us say center of mass of 2 bodies, of a 2 body system. I will choose a coordinate axis, let us say it is a 2-dimensional coordinate axis, or can be 3-dimensional also, then 3-dimensional I will draw the z axis. For simplicity I am not drawing that. Let us say m1 is a mass which is whose position vector, this is the origin, let us say this is the y axis, this is the x axis, m1 is the position vector of mass m1 is r1 and the position vector of mass m2 is r2. Then the center of mass will be, let me change that, let us say here. If you join these 2 masses, center of mass will be somewhere in between. If there are 2 bodies, then the center of mass is a point between the 2 masses. Join the 2 masses somewhere here, somewhere whose position vector is given by this position vector, let me write it as RCM. Then RCM by definition, the position vector is m1 r1 plus m2 r2 divided by m1 plus m2. This is the mass of the system, total mass of the system. This is the position vector of m1, this is the position vector of m2. So, this is the definition of the center of mass for 2 body system. Now, if there are more number of bodies, then you just simply extend this m1 r1, m2 r2 plus m3 r3 plus m4 r4. That means, you consider that that body consists of n particles now. Instead of 2 particles, now I can consider this body having m1, m2, m3, m4 and mn up to n number of particles, and I will add this n number of times m1 r1, m2 r2, m3 r3 and mn rn parjanta, and divided by m1 plus m2 plus m3 up to mn. So, that is for n number of particles. Now, if it is a rigid body, if it is a continuous body, the bodies are so close by m1, m2, m3, m4 sabu pakhapakhi emti achanti. So, in that case what we do is 1 by total mass. So, we write RCM. Similarly, 1 by total mass jaha mass achi system ro sabu jaka mass misei kiri m1 r1. If the small mass dm is at r, then we integrate it for the entire body, we integrate it, and this is the definition of center of mass. So, we have to integrate. You have to write dm, what is the mass of a body whose position vector is r. So, that you have to write, that value you have to write and then integrate. Now, see, this is a vector, this is a vector, means it has 3 components, x component, y component and z component. Similarly, here तार जदि components हिसाब रे मु लिखिबी, this is x component will be equal to m1 r1 रो x component x1 plus m2 x2 by m1 plus m2. Now, since this is along x direction, I am not giving the vector sign here, the arrow is not given because this is a scalar quantity and I understand that this is along x axis. The direction is already defined. When I write x, means it is x axis along YCM. The y component of this will be similarly m1 y1 plus m2 y2 divided by m1 plus m2, and z component will be equal to m1 z1 plus m2 z2 by m1 plus m2, where I represent that my RCM vector is actually XCM I cap plus YCM j cap plus ZCM k cap. You have read I cap is the unit vector along x axis, this is unit vector along y axis, this is unit vector along z axis. So, and x1 y1 r1 vector is x1 I cap plus x2 y2 j cap, sorry y1 j cap plus z1 k cap, and r2 vector is r2 I cap plus x2 j k I cap y2 j cap plus z2 k cap. So, corresponding जोटा x component नबो माने corresponding r1 रो x corresponding component टा नहीं गले you can find it out. So, if this is the position of center of mass, what is the velocity of center of mass, what is the acceleration of the center of mass, that will give us the center of mass motion. So, the center of mass motion can be found out by simply finding out the derivatives. So, if I try to find out motion of center of mass, see, I have RCM, the vector equals to m1 r1 vector plus m2 r2 vector. Remember the diagram that we started with this. This is a vector relation. So, the velocity of center of mass, velocity is also a vector, velocity of center of mass. This is, let me write VCM will be equal to simply the time derivative of position RCM. Velocity is rate of change of displacement. So, derivative of displacement. So, here the position of center of mass is this, tar derivative, time derivative will be velocity of that thing, that is the velocity of center of mass. Cm here stands for center of mass. So, this is, if I derive m1 is a constant, r1 रो derivative केवल हबो. So, m1 dr1 by dt plus m2 dr2 by dt by m1 plus m2. Now, what is this? This is nothing but this quantity is velocity of the first particle and this is the velocity of the second particle. So, this is m1 v1 plus m2 v2 by m1 plus m2. So, this is the formula for the velocity of the center of mass. That means, I can say that if I take this to this side, m1 plus m2 times velocity of center of mass is equal to m1 v1 plus m2 v2. Now, you also know mass into velocity is momentum of the first particle. So, this is P1, this is the momentum of particle 1, momentum of m1, and this is a vector. This quantity product is P2 or this is the momentum of particle 2. Now, if this is the total mass, m1 plus m2, there are two bodies, two particles, m1 and m2, so total mass is m1 plus m2. This tells me that the momentum of m1 plus momentum of m2, this is nothing but the total momentum of the system, because the system consists of two particles, janakar m1 v1 or janakar m2 v2. So, you have added this. So, the total momentum of the system is nothing but equal to total mass into velocity of center of mass. Ta mane momentum of the center of mass. Ta mane this is, if I can consider, say that this total mass is at center of mass, then this represents, this quantity represents the momentum of center of mass. So, the momentum of center of mass, ता माने center of mass रे को mass अच्छी, total mass अच्छी. ता माने मु आउ दीटा particle को न धरी गिरी भाभी भी जे center of mass रे m1 plus m2 मिसी किरी गोटे body अच्छी जहार mass m1 plus m2 सेठी रखी देबी तारो momentum बाहर को is nothing but the momentum of the two particles. तेणु मु आउ दीटा particle को अलगा अलगा न देखी किरी I will find out the velocity of the center of mass. तेणु मु I can know that this mass, this whole system केते velocity रे जाउची. So, the momentum of center of mass is the total momentum of the particles. So, momentum of 1 and plus momentum of 2. 2 means the first particle, this is second particle. So, this I get from the velocity. What about acceleration? See, all these things I am talking about linear, everything as a whole, not rotational. Acceleration is, by definition, acceleration is equal to rate of change of velocity. So, acceleration is dv by dt. So, we will find out the acceleration of center of mass. So, acceleration of center of mass will be dvcm by dt. This is the velocity of center of mass. तार derivative मु बाहर करी. So, this is equal to, now right hand side रे कौन ना एटा. This is my vcm. ताकू derivative करी. So, m1 तो constant, ताकू तो derive करिवार किछि ना. m1 dv1 by dt plus m2 dv2 by dt. तामाने मु को लेखुची d by dt of this quantity. d by dt of this quantity is this by m1 plus m2. एटा तो constant, एटा तो m1 plus m2 change not changing. किए change होची v1 और v2 change होची with time. तेणु तांकर केवल derivative बाहरिवो. Now, what is dv1 by dt? Rate of change of velocity with time. तामाने एटा होची acceleration of first particle. This is nothing but the acceleration of second particle. So, this is equal to m1 a1 plus m2 a2 by m1 plus m2. Similar type equation, आरंभ प्रथम equation जो type रो एठी position थिला r1 r2, एठी velocities आसीगला, एठी acceleration आसीगला, nothing much different. So, m1 a1, where a1 is the acceleration, these two are acceleration of particle of m2, a1 is acceleration of m1. So, acceleration of center of mass is this. So, acm is equal to m1 a1. तुमको जदि individual particle रो acceleration जଣା अछि, a1 a2 तमे जानिचो, m1 m2 तमे जानिचो, then you can find out the acceleration of the center of mass. Center of mass टा केते acceleration रे जिवो, that you can calculate from this formula. Now, as before, मु एठी जेमति एटा को एपट को आनी के कहिली जे एटा होची total mass जदि अछि तार vcm अछि velocity, this is the total momentum of the center of mass. मु एटा को ए आड़ को आनिबी. So, I get m1 plus m2 times acm. acm is the acceleration of center of mass, this. So, this equals to m1 a1 plus m2 a2. what is mass into acceleration? Force. So from Newton's law we know mass into acceleration is force. Now this is for first particle, this is for second particle. That means this is the force on particle 1 or m1, this is the force on m2. So this, let me write it as F1, where this is force on m1 plus this is the force on m2. How did I get this? From the equation m1a1. F1 is m1a1. So this is my F1. m2a2 is F2. Now this is equal to, let us say, acha gote particle upare kon force achi. Now let us say that this is the external force on 1 plus force on 1 due to 2. Mark this. This is force on m1 by m2. तामाने m2 m1 को यही force टा दोची. Always there are some internal force. That means this is an internal force, not external. बाहरु किए जेते force m1 ऊपरे पड़ुची, I am writing that as F1 external plus. So this is the force. This is my F1. This is F1. फर्स्ट पार्टिकल उपरे ए दुईटा फोर्स अच्छी. सेकेंड पार्टिकल ताको अट्रैक्ट करुच्ची कि रिपेल करुच्ची जही हेले गोटे फोर्स अच्छी आउ एक्सटर्नल बाहरु मध्य किछि फोर्स अच्छी. ठीक सेमती F2 उपरे एक्सटर्नल रु गोटे फोर्स आसुची प्लस F2 फोर्स ड्यू टू 1 फर्स्ट पार्टिकल जोगु सेकेंड उपरे. दिस इज द फोर्स ऑन M2 बाय M1. Now from Newton's third law, action reaction are equal. तामाने फर्स्ट पार्टिकल जदि सेकेंड पार्टिकल को गोटे फोर्स दबो, सेकेंड पार्टिकल सेति की फोर्स फर्स्ट पार्टिकल को दबो इन अपोजिट डायरेक्शन. ता माने कोन हैला F12 हैला फोर्स ऑन M1 बाय M2, F21 हैला फोर्स ऑन M2 बाय M1. तामाने ए दुईटा का फोर्स इक्वल एंड अपोजिट. सो फ्रॉम दिस these two are equal एंड अपोजिट. अपोजिट माने उल्टा डायरेक्शन रे जदि दुईटा फोर्स इक्वल एंड अपोजिट एक्ट करुची ता माने दिस प्लस दिस मिसेले 0 होबो. सो दे विल कैंसल आउट. दे विल कैंसल आउट. ता माने आई कैन राइट F12 इज माइनस F21. उल्टा डायरेक्शन रची सेथिमाई माइनस आ मैग्नीट्यूड दिनो जाकंकर समान. सो ए दुईटा कैंसल हो गला माने बलिला कौन F1 उपरे एक्सटर्नल फोर्स प्लस F2 सेकेंड पार्टिकल उपरे एक्सटर्नल फोर्स. ए दुईटा ही एक्सटर्नल फोर्स. तामाने दिस इज द टोटल एक्सटर्नल फोर्स. दिस इज टोटल एक्सटर्नल फोर्स ऑन द सिस्टम. So analyze this equation. This equation tells this is the total mass of the system. Total mass is m1 plus m2. Total mass into acceleration of center of mass. Mass into acceleration is always a force. तामाने this must be equal to force. So total mass into acceleration of center of mass is nothing but equal to external force. तामाने you forget about the internal forces. बाहरु जेतक external force पड़ुची से गुड़ाक जदि m1 plus m2 उपरे act कले तेबे acceleration हबो ACM. तामाने I can consider that all the external forces are acting on the center of mass where the total mass m1 plus m2 is present. So this is the meaning of that whole thing, and that is how we defined the center of mass. It is a point which behaves as if the entire mass of the system is concentrated and all the external forces are acting there. So this is the mathematical equation of that. That what does it tell you? That external force, the entire external force on the system is equal to the total mass, if I can write this as capital M into a center of mass. This is the total mass. So तमे consider करो जे total mass टा जोठी center of mass अच्छी सेठी पड़ू अच्छी आउ तार से point रो acceleration जदि ACM हुए, then the external force F is equal to mass into acceleration. So आमको आउ एते M1, A1, M2, A2 एगुड़ा एते कथा चिंता करिया दरकार नहीं. If I can find out the center of mass, and I know the external forces, I can find out the acceleration of the center of mass. So, acceleration of center of mass जानile I can solve about the system. सब individual particle को नहीं करी मते सब individual particle धरा 8000 टा particle अछि मु को लिखी भी एकनी F1 is equal to M1A1, F2 is equal to M2A2 एमती 8000 टा लिखी भी ताकू मिसेइबी ताकू solve करीबी. Instead of that, what I do is I try to solve only this equation. मु external force केते अछि देखिबी, total mass केते अछि, बस I can find out the acceleration of the center of mass. Once I know the acceleration of the center of mass, the whole system ro solution jaha bahar kariar अछि is always done with respect to the center of mass. Hele asubidha kiछि hobani. So this is the reason why we use center of mass, and this is how the center of mass motion takes place. And next class carry on, we will calculate center of mass of some body like uniform rod, and then we will move over to rotational motion and other things. Thank you.